Good morning. Okay, what we're going to be talking about today is it's more factoring and then solving for x after we have factored. Okay, we've done this before, but I'm going to give you a quick reminder of what it's all about. We have this equation. Y equals x squared plus 10x plus 24. Okay, so we are going to factor that, but before we do that, let's just take a look at what that looks like as a graph. So this is the graph of y equals x squared plus 10x plus 24. Notice it's a parabola. It starts up here, it comes down, it reaches a minimum here, and then it starts going back up. So there's something that happens to the numbers with this x squared that creates that kind of a shape. And also notice that there is perfect symmetry. There is what we call the axis of symmetry, a line right in the middle of this parabola that if I actually folded it in half, the two lines would be right on top of each other because there's perfect symmetry. Whatever the distance is from the middle, which is right here, from here to here is the exact same distance as it is from here to here. Here to here, exactly the same as it is from here to here. And that works all the way through. Okay. All right, so why do we factor? The point of factoring is to figure out the zeros. And when we say zeros, what we're talking about is the places where we cross the x-axis. So this graph, again, it's coming down. It's passing the x-axis. Here's our x-axis. So it's passing it at -6 and -4. Those two spots. And these are key spots on any graph. This graph is positive above the x-axis. It's negative. The numbers are all negative below the x-axis. So those are important bits of information when these are used in real-world problems, which they are quite a bit. Okay, so we are looking at factoring. And we do this to find the x-intercepts. Okay. Intercepts. Sorry about that. Okay, so these are the x-intercepts. We also call that to find the roots. These two numbers, -6, -4, those are also called the roots. We say solve, and that also means look for roots, or to find the zeros. So those are all different ways that we would be saying, look for the place where this graph crosses the x-axis. Okay. So the way we have learned to do it so far is to factor. So we're going to factor this equation. And this is a 1. So there's no trick to this other than just put my parentheses, what times what gives me x squared. In other words, what's the square root of x squared? X and x. Now I want product of 24. And I want a sum of 10. And both of these numbers are positive, and it's important to make note of that. And I'm going to make my t, and I'm keeping track of my numbers. Now, hopefully, when you've done this enough, you will start seeing how the numbers work. Making the tree is crucial to getting to that point. If you're skipping steps, if you're trying to do this just through your head, you're losing the numbers, you're not seeing the combinations clearly. So please write it down. You will start seeing the numbers much faster. You will not be spinning your wheels. You won't be wasting time. It will make you go faster. So just to give you an idea, when we say look for those factors that equal 24, there's 1 times 24. There's 2 times 12. We're looking for every combination. Every combination. And it's much faster when everything is positive, but we even double this when this is negative, if this is negative and this is also negative, because then we've got combinations of negatives and positives. Okay, so we have 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 doesn't work, 6 times 4, it just goes backwards, 7 doesn't work, 8 times 3, it's going backwards. So from that point, we're going backwards, so we don't need to write any more combinations. Now we look at the sum of those two numbers. 1 plus 24 is 25. That did not work. It didn't give us 10, and that's what we're looking for, the magic number of 10. And hopefully you're seeing it here. 2 plus 12, that equals 14. Now if these were negatives, then I'd be subtracting one number from the other and getting that combination. That didn't work. I need 10. 3 plus 8, that equals 11. Again, didn't work. 4 plus 6. There we go. That equals 10. Yay. That's what I'm looking for. Those are my two numbers. So, and they're both positives, so plus 4 plus 6. Okay, now I have factored it completely. And I'm going to set it equal to 0. Because what am I doing? I am factoring to find the x-intercepts, which means I'm going to factor to solve. Say factor and solve for x. So that's my goal here. Factor, solve for x, which means I'm looking for the x-intercepts, or I may say, you may be taking a state test and it says, look for the roots, factor and find the roots, or factor and find the zeros. All mean the same thing. I'm going to factor, then I'm going to take this apart. Bring this one over here, this one over here. X plus 4 equals 0, x plus 6 equals 0. Now I have a basic, simple Algebra 1 problem, and I just solve. If I want to get x by itself, subtract 4 from both sides. The 4 crosses out. Bring the x down, and x equals negative 4. Looking at this one now, I go to the next one. Subtract 6 from both sides. Cross out the 6. Bring the x down. X equals negative 6. Now I note negative 4, negative 6. Oh, look at here. That is a negative 4. This root is a negative 6. I can check my answer right there to see if it's right. And I know that it is because I'm looking at the graph, and that's the x-intercepts. So when I factor, I solve for the x, and then I find the x-intercept. It's that simple. Now you're going to do a couple of practice problems.